welcome back to the course on computer network and the internet protocols. So, in the last class, we are looking into this concept of IPv4 addressing, and we have looked into the concept of classful and the classless addressing scheme with the help of subnetting and the supernetting. So, today we look into a specific example about this subnetting and supernetting, and given a larger address pool, how can you construct multiple subnets out of that particular address pool. So, we have looked into this basic addressing format in CIDR. So, you have a IP address and a corresponding subnet mask. The subnet mask determines that how many number of bits are there in your subnet IP field. So, here in this particular example, your this many number of first 8 plus 4, that 12 bits are your network IP, and the remaining bits are for the host address. So, this gives your subnet boundary. So, these bits are for your subnet IP, and the remaining bits are identifying the host inside that particular subnet. So, let us look a few example of subnetting, that how can you actually have this kind of hierarchical addressing concept in network. So, assume that the IP address of a network is 203.110.0.0/16. So, this /16 in CIDR notation means you have 16 bits in the network IP field, and the remaining 32 minus 16, that means the 16 bits are for host addresses. So, that is the address pool that is given to you. Assume that that is an organization network. This organization network, it has this border router from the central IP allocation authority. In case of India, it is APNIC. From there, they get this particular pool of IP address, say 203.110.0.0/16. So, that is the IP address which is denoting this entire network. Now, in this network, say the organization want to divide this network into 3 subnets. So, inside this network, I have say 3 subnets. This is one subnet that they want to create, then this is say another subnet that they want to create, and say a third subnet that they want to create. So, they want to create these 3 subnets. So, the question comes that how will you divide this entire address pool into 3 different subnets. So, the first question comes that how many bits do you require to have 3 subnets. So, to create 3 subnets, indeed we require 3 bits and not 2 bits. Why not 2 bits? Because we want to avoid again all zeros and all ones in the subnet addressing field. So, this 203.110.0.0/16, it says that well this 203.110, this part is my network address part, then I have 16 different bits. So, I have 8 bits here followed by 8 bits here. These 8 bits plus 8 bits 16 bits I can use to create the subnets. Now, whenever I am creating the subnet, if I have to create 3 subnets, I have to take certain number of bits from the host. So, whenever we are taking certain number of bits from the host, to create 3 subnets, we should not take 2 bits. So, because if you are taking 2 bits, your subnet IP, so say here you are taking 2 bits, if you are taking 2 bits here, so one subnet IP can be 01, then the host address part, another one can be 10, then the host address part, the third one need to be either 11 or 00. So, if you are using all ones on all zeros, then there are certain problems. So, let us see what is the problem there. So, the problem of all zeros and all one subnets are something like this. Say if you are using all zeros as a subnet IP. So, here this particular router has the IP address of 192.168.00/16. Now, say you create a subnet by taking this 0 at the subnet indication part. So, this one I want to divide into two subnet. Now, in this subnet I am using this 0 to denote one subnet and this 1 to denote another subnet. Now, if you use this 0 to denote this subnet, now considering the network address part and the subnet part, I have 17 bit which is being used for denoting this subnet. But interestingly, if you use 0 as an identifier for this subnet, the network address for this subnet is equal to the network address for your original network. So, the network address for this subnet will be 192.168.0.0. The network address for this subnet will also be 192.168.0.0. And that is why we normally refrain from using all 0 subnet, because if you are using all 0 subnet, we call it as subnet 0. So, if you are using all 0 subnet, then you may have a problem like the subnet IP becomes equal to original to your the original network IP. Similarly, for the all 1 subnets, here you see that whenever you are creating a subnet like 192.168.128.0/17, so here I am taking this 1 as the subnet identifier, the subnet indicator. So, if I take this 1 as the subnet indicator, so in that case my subnet IP comes to be 192.168.128.0. So, 1 followed by all zeros. If 1 is here, then all zeros, then this comes to be 128 in decimal format. So, in that case, if you try to find out the broadcast IP for this subnet. So, the broadcast IP for this subnet will be equal to all ones in the host bits, okay. Then all ones. So, this is equal to 255, this is equal to 255. So, the broadcast IP for this subnet is 192.168.255.255. Now, what is the broadcast IP for the original subnet? So, the broadcast IP for this original subnet is again, because this is a 16 bit. So, I need to make all these bits as 1. So, it is 192.168, then all ones and all ones. So, 192.168.255.255. That means, the broadcast IP for this subnet becomes equal to the broadcast IP of the original subnet. So, that is the problem of all one subnet. So, if you find out the broadcast IP for this subnet, the all 0 subnet, that will be different, that will be equal to 192.168.0, then all ones dot all ones, that would be different, but the problem is that the network IP for the subnet becomes equal to the network IP of the original network. That is the problem for subnet 0. For subnet 1 or all 1 subnet, the problem becomes that the broadcast IP for the original network becomes equal to the broadcast IP of your subnet. So, that is why we do not use the all zeros and all ones in a subnet IP field. So, in the previous case, again if you are going to use 2 bits to denote 3 subnets, then either you have to use 00 as a part of the subnet or 01 as a part of your subnet IP. So, you do not want to use that to avoid all zeros and all one subnet. So, you need to use 3 bits for doing this subnets. Now, if you want to use 3 bits for doing this subnet, your subnet IP can have the IP of 100, subnet 2 can be 101, subnet 3 can be 110. And the remaining 13 bits can be used to addressing the hosts inside those subnets. So, in that case, if you are using 100 as the subnet IP, the subnets becomes 2.3.110.128.0/19, that is so that is the subnet mask, because we are taking 3 bits from the host address to denote the subnet. So, the subnet mask becomes 16 plus 3, that is equal to 19. The second subnet, if you are using 101, then the second subnet in the dotted decimal format becomes 203.110.160, 101 followed by all zeros, 0/19. If you are taking 110 it becomes 203.110.192 110 followed by all zeros by a decimal equivalent of 192 followed by 0/19. So, that way you can create 3 different subnets out of the network IP that is given to you. Now, let us see another concrete example of CIDR. So, I have taken an scenario of IIT Kharagpur. So, this is our Computer and Informatics Center. So, our CIC they have taken IP pool from APNIC. Say the IP pool they are getting is 203.110.0.0/19. So, if this IP pool is given to them, that means the 19 bits are for the network address, and then the remaining 32 minus 19, that means 13 bits they can use for the host address. Now, with this 13 bit at the host address, which is their total inside IIT Kharagpur. Now, assume that we are just concentrating on 3 different departments of IIT Kharagpur: CSE, Computer Science, VGSOM, Binod Gupta School of Management, and Electrical Engineering E. Now, assume that the CSE has 2000 hosts, VGSOM has 500 hosts, and E has 500 hosts. And with this 13 bit at the host field, you want to create 3 different subnet. One subnet is for CSE, the second subnet is for VGSOM, and the third subnet is for E. So, the question comes that with this 13 bit, how will you do that? So, first let us do an estimation that to address this many number of hosts, how many bits do I require? Now, to address 2000 hosts, you require at least 11 bits, because 2 to the power 11 becomes equal to 2 to the power 11 is 2048. So, with 11 bits you can support 2000 number of hosts, and then 9 bit is required to support VGSOM. 9 bits means you can support 512 minus 2, that means 510 number of hosts. So, that is for VGSOM. Similarly, for E you require 9 bits. Now, here you see that if you are the maximum number of bits that is required to having this host is 11 bits. So, if that is the case, then if you are taking 11 bits to addressing the host, then there are only 2 bits remaining, because here you can have a total of 13 bits from this subnet mask. You can get a total of 13 bits to denote the host, and out of the 13 bit, if you require 11 bits to denote a host, only 2 bits are required for only 2 bits are remaining for doing the subnetting. And as we have looked earlier, that using 2 bits you cannot do the subnetting properly. So, here we apply the concept of supernetting. So, let us see that how we apply the concept of supernetting here. So, what we do, so that is the entire thing. So, our address space was 203.110.0.0/19. So, we have 13 bits which are available to serve all the hosts of IIT KGP network, and we need to divide this address space among 3 subnets. And what we have seen that CSE requires 11 bits, VGSOM requires 9 bits, and E requires 9 bit for their host address. So, we have only 2 bit left for identifying the 3 subnets. So, again to avoid all zeros and all one subnets, this is not possible. So, here we apply the concept of supernetting. That means, we combine VGSOM and E network together. So, if you combine VGSOM and E network together, let us see what happens. So, we are combining VGSOM and E together. So, together now they have 500 plus 500, that means 1000 number of hosts, and to address those 1000 number of hosts, 10 bit at the host address space is sufficient. And now, with the remaining 2 bit, you can always divide it into 2 different subnets. So, what we are doing here, we are putting this additional router here in between. That router is helping me to treat this entire subnet as this combination of these 2 subnet as a entire network. So, now I do not need to divide it into 3 subnet. From here I need to divide it into 2 subnet, and using 2 bit I can safely divide it into 2 subnets. So, what I can do that now CSE requires 11 bits, VGSOM plus E together they require 10 bits. So, with 11 bits I can serve all the host. So, what I do that that was my original network address 203.110.0.0/19. So, with 19. So, this is up to my network address place, and this x that we can use as the host and the subnet. So, we take these 2 bits. So, using these 2 bit we divide it into 2 different subnet. One subnet is for CSE, another subnet is for this VGSUM plus E. So, let us use 10 to denote the CSE network. So, in the place of these 2 bits. So, if I use 10 here, then I have this 8 plus 3 11 number of bits available to address all the hosts in the CSE network. So, my IP address for the CSE network becomes 203.110.16.0 / now I have taken 2 bits here at the network address space. So, this becomes 19 plus 2, that is 21, and the VGSUM plus E network address it becomes. So, these 2 bits I am making them as 0 1. So, I am avoiding all zeros and all ones here, and so the VGSUM plus E network, that is the combination of that subnets, the supernet, they have the address of 203.110.8.0 /21. So, 8.0 because this 0, this 1, and then again all zeros in the place of x, the way we get the network address for a particular subnet. So, we get this address for the VGSUM plus E network. Now, so this is our scenario. So, this was my entire address pool. This entire address pool I have divided into 2 subnet. One subnet is going to CSE and the second subnet is going to VGSUM plus E. Now, this second subnet again I have to divide it into. So, after this router, so this intermediate supernetting router that I have placed here. So, after this router I have to again divide this address pool into 2 different subnet. One subnet is for VGSUM, another subnet is for EE. So, here we see that well the 21 bits have been used for the network address space. So, I have 11 bit, total 11 bits remaining. So, total 11 bits are remaining and VGSUM requires 9 bits and EE requires 9 bits. So, my life is simple here. So, now VGSUM requires 9 bits, E requires 9 bits. This is my network address. So, this network address, these 2 bits I have already used in the previous step of subnetting to make a combination of VGSUM plus E network. Now, we use the next 2 bits. So, this using this next 2 bits I can differentiate between VGSUM network and the E network. So, for the VGSUM network I am giving a network IP of 10 and to the EE network I am giving a network IP of 01 to this EOLOXX place, and accordingly I get the VGSUM network address as 203.110.12.0/23. Earlier it was 21. I am taking 2 bit from the host and putting it at the network. So, the subnet mask becomes 23 and the EE network it becomes again 203.110.10 in the dotted decimal format .0/23. So, that way now I am able to, with the help of this subnetting and supernetting, I am able to distribute this entire IP address space that was given to me into 2 different subnets. So, or 3 different subnets in a hierarchical way. So, initially we divide it into 2 different subnet where I have CSE in one side and the combination of VGSUM plus E in another side, and in the next step I have divided this the second level of IP address to the VGSUM network and the EE network. So, that way in a hierarchical way you can, once you are getting a pool of IP addresses for your institute, you can divide it into multiple smaller subnets and allocate the IP addresses to the individual subnets. There is another interesting fact in CIDR, because we do not have this kind of fixed class boundary what we can do, that we can use what we say as the variable length subnetting. So, we use something called a variable length subnetting. What is this variable length subnetting? So, in the earlier example, in this particular example, if you look into this particular example, here actually we are using something called the fixed length subnetting. So, what we are doing, that whenever we are breaking this entire thing into two subnets, for both the subnets we are using /21 as the net mask. Similarly, whenever in the second level we are dividing it into VGSUM and E, we are again using for both the cases /23 the equal length or the similar length or the fixed length subnet mask or net mask. But CIDR does not restrict you to use this kind of fixed length subnet mask. You can always use variable length subnet mask. That means, for one subnet you can have subnet mask of length n. For another subnet under the same network, you can have subnet mask of say length m, which is different from n. So, let us see that how you can utilize variable length subnet mask for this particular example, variable length subnet mask. So, let us see an example of variable length subnet mask. So, assume that your network IP that was given to you is 202.110/0/0/20. Now, with this you have 20 bit at the network IP network address space, network prefix. So, you have 12 bits for hosts. So, if you have 12 bits for host, that means you can support 2 to the power 12 minus 2 this many number of host, that means equal to 1024 minus 2, 1022 number of host. Now, assume that you want to divide it into 3 different subnets with subnet 1 having 1000 hosts, subnet 2 having say 500 hosts, and subnet 3 having another 500 hosts. Now, if this is the case, then for subnet 1 you require 10 bits, because 2 to the power 10 equal to 1024. For subnet 2 you require 9 bits, for subnet 3 you again require 9 bits. Now, here you see that you have only 2 bits are available if you are using 10 bits for doing the subnetting. So, in case of if you want to use a fixed length subnet mask for all the subnets, then you can at least keep provision for 1000 hosts for all the subnets, that is the maximum number of hosts which is there in any of these 3 subnets S1, S2 and S3. So, in that allocation you require 10 bits for the host address part and 2 bits are remaining for the network prefix. If 2 bits are remaining for the network prefix, just by avoiding all zeros and all one subnet, you will not be able to do that, because with 2 bits you need to avoid 0, 0 and 1, 1 as the subnet prefix. But using variable length subnet mask you can do that. So, what will be that variable length subnet mask? Say my network IP is 202.110. Now, for S1 what I do, that I take 2 bits to denote the subnet mask. So, for S1 I am taking these 2 bits and then the remaining bits are host bits. The host bits I am writing as x dot x x x x x x x x. So, this can be the network address for S1. Now, here what we are doing, my net mask could be earlier it was 20, I am taking 2 bits. So, the net mask could be 22 bits. Then in the second case, for these 2 hosts it is not required that you have to use /22 as the net mask with the help of this variable length subnet mask, which is being supported in CIDR. So, what you can do here, you can take 3 bits. So, while you are taking these 3 bits, you need to be little cautious. Let me say what is that. So, 202.110.101, then you take 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 slash 23 as your net mask. So, here I am taking 101, but whenever I am taking 101, the interesting fact is that this 101, so this 01 is not a prefix of this 101. So, if you take this one as 010, you see that 010 instead of taking 101, if you take 010, 010 can be a host of the subnet S1. So, that one we should not take. So, we should not take 010. So, we should take something which is not becoming a prefix of the original one. And for S3 similarly, I can make the subnet as 110 slash 100 then slash 23. So, that way by using this variable length subnet mask, where I am using slash 22 as the subnet mask here, slash 23 as the subnet mask here, and then again slash 23 as the subnet mask, I will be able to solve this IP allocation problem, which was not possible with this fixed length subnet mask. So, that is one of the advantage of CIDR. So, these examples that I have discussed today, so these examples give you an idea about how you can effectively do IP allocation to a machine using this IPv4 addressing scheme of a host in a network by considering this IP hierarchy, where you have this concept of network address which will uniquely identify a network, and then the host address which will uniquely identify a host inside that network. So, that is the way we use this concept of address hierarchy to provide unique addresses to, or unique IPv4 addresses to all the hosts inside the network. In the next class, we will look into the routing mechanism, the CIDR routing mechanism, which is being utilized by using this IPv4 addressing, and we will also look into that how you can effectively utilize IPv4 addresses with the help of a concept called network address translation, and we will look into the concept of IP version 6 in brief, and give you a little bit overview about what IPv6 is and how it is different from this IPv4 addresses. And interestingly, that is actually one of the biggest failure in computer network, this IPv6 addressing, but what is the reason behind that failure, we will discuss that. So, that would be interesting for you. So, thank you all for attending this class. We will meet again during the next class.